Imagine looking up at the night sky and seeing the moon, not glowing peacefully above you, but cracking apart a T first. There would be a strange silence. A thin fracture would appear across the lunar surface, stretching farther and farther until the moon itself could no longer hold together. Mountains would split, craters would break open, massive pieces of rock would separate from the lunar surface and begin drifting into space. It sounds impossible, but imagining it reveals just how important the moon really is to Earth. The moon is not simply a beautiful object in the night sky. Its gravity influences our oceans, affects Earth's rotation, and helps stabilize the planet's long-term orientation. If the moon suddenly shattered, Earth would not instantly explode, but our world would begin entering a completely different chapter of its history. The first danger would come from the debris. If the moon broke apart violently, countless fragments would spread along its orbit. Some would remain in orbit around Earth, creating a spectacular and terrifying ring of lunar debris. Others could collide with one another, producing even more fragments. Over time, some pieces could fall toward Earth. Imagine watching the sky as enormous rocks streaked through the atmosphere, glowing brighter than any meteor shower humanity had ever witnessed. Most small fragments would burn up, but larger pieces could survive the journey and strike the surface with tremendous energy. Cities would look toward the heavens in fear as the familiar moon disappeared and was replaced by a constantly changing cloud of rock and dust. But the destruction would not necessarily end with falling debris. The moon's gravitational pull is one of the major forces responsible for Earth's tides. Without a single dominant moon, ocean tides would become dramatically different. The sun would still create tides, but the powerful lunar influence would be gone or distributed among smaller fragments. Coastal ecosystem. The moon suddenly breaks apart. A catastrophic fracture could split the moon into countless pieces, creating a massive cloud of lunar debris around Earth. Imagine stepping outside one night and looking toward the moon, only to notice something impossible, a giant crack stretching across its surface. At first, it might appear like a small fracture, but within moments, the crack could spread across mountains, valleys, and ancient craters. The moon, which has remained a familiar presence in Earth's sky for billions of years, could begin breaking into enormous pieces. If the breakup were caused by a massive internal disturbance or an external impact, the consequences would depend on how violently the moon shattered. A gentle fragmentation might leave countless pieces traveling in similar orbits around Earth. A violent breakup, however, could send debris in many directions, creating a rapidly expanding cloud of lunar rock. Some fragments would collide with one another, producing even smaller pieces. Others could settle into new orbits around Earth, potentially forming a spectacular ring of dust and rock. From the surface, the familiar full moon could disappear and be replaced by a strange, glowing band across the night sky. The most frightening possibility would be fragments falling toward Earth. Small pieces would likely burn brightly in the atmosphere, creating meteor showers unlike anything humanity had ever witnessed. Larger fragments could survive atmospheric entry and strike the surface with enormous energy, potentially causing destruction over wide areas. Yet Earth itself would not instantly be destroyed. The planet would continue orbiting the sun, and life would continue. But humanity would suddenly realize that the peaceful object we had always considered permanent was never truly invulnerable. The moon's destruction would transform the night sky and mark the beginning of an entirely new chapter in Earth's cosmic story. Lunar debris threatens Earth. Some fragments could enter Earth's atmosphere, producing spectacular meteor storms, while larger pieces could potentially impact the planet. Once the moon began breaking apart, the greatest concern would no longer be what was happening in space, but what would happen to the pieces afterward. The moon contains an enormous amount of rock, and even a small fraction of that material entering an unstable orbit could eventually become a threat to Earth. The debris would not simply fall straight down. Each fragment would follow its own trajectory, influenced by Earth's gravity, the moon's remaining mass, and interactions with other pieces, Smaller fragments could collide with one another and create clouds of dust and gravel. Some would remain in orbit, while others could gradually descend toward Earth. As these pieces entered the atmosphere, they would encounter tremendous friction and heat. The night sky could suddenly become filled with brilliant streaks of light, producing meteor storms far beyond ordinary meteor showers. Most tiny fragments would burn up before reaching the surface, but larger pieces would be much more dangerous. A sufficiently large lunar fragment could survive atmospheric entry and slam into Earth at enormous speed. The resulting impact could create powerful shock waves, intense heat, and massive craters. If several large fragments arrived within a relatively short period, the consequences could become severe for human civilization and ecosystems. Yet the danger would not necessarily mean the end of Earth. Our planet is enormous compared with even a large lunar fragment, and much of the debris would never reach the surface. Some pieces could remain trapped in orbit for thousands or millions of years. Earth's oceans would change. Losing the moon's dominant gravitational influence would dramatically alter tides and disrupt coastal ecosystems and marine life. If the moon were suddenly destroyed, one of the most immediate long-term changes on Earth would involve the oceans. The moon's gravity is a major force behind Earth's tides, constantly pulling on the planet's oceans and creating the familiar rise and fall of coastal waters. The sun also produces tides, but its influence is weaker than the moon's because the moon is much closer to Earth. If the moon broke into countless fragments, its gravitational influence would become distributed among those pieces. The exact tidal effect would depend on how the debris was arranged and how much mass remained together. Earth would not suddenly lose all tides because the sun would continue pulling on the oceans. However, tidal patterns could become significantly weaker, irregular, or unpredictable. For coastal ecosystems, such a change could be enormous. Many organisms have evolved around regular tidal cycles. Certain marine animals feed when tides expose coastal areas, while others use tidal rhythms for reproduction, migration, or navigation. Wetlands, mudflats, estuaries, and tidal pools could gradually change as the movement of seawater became different. Human communities near coastlines could also experience major changes. Harbors, fishing grounds, and coastal environments are all influenced by tidal patterns. A different tidal system could reshape beaches and wetlands over time, while changing where sediment accumulates and where erosion occurs. Earth's long-term stability could be affected. The moon influences Earth's rotation and axial behavior, so its disappearance could create major changes over extremely long timescales. The moon does more than influence Earth's oceans. Over enormous periods of time, its gravity also interacts with Earth's rotation and helps stabilize the planet's orientation in space. If the moon suddenly disappeared or broke into widely scattered fragments, Earth would not immediately start spinning out of control, but the long-term effects could become important. Earth rotates around an imaginary line called its axis. That axis is tilted relative to the planet's orbit around the sun, and this tilt plays a major role in creating our seasons. The moon's gravitational influence helps keep variations in Earth's axial tilt relatively controlled over long periods. Without the moon acting as a stabilizing gravitational partner, Earth's orientation could potentially experience larger changes over geological timescales. Such changes would not happen overnight. There would be no sudden worldwide transformation the morning after the moon disappeared. Instead, over millions of years, variations in Earth's orientation could influence climate patterns and the distribution of sunlight reaching different regions of the planet. Different parts of Earth could experience changes in seasonal intensity. Long-term climate patterns could shift, affecting ecosystems and species that depend on relatively stable environmental conditions. Some regions might experience greater extremes between seasons, while others could undergo entirely different climatic cycles. Earth's rotation would also continue evolving because of interactions with the sun, oceans, atmosphere, and other gravitational forces. The moon is only one part of a much larger cosmic system, but removing such a massive nearby body would change that system significantly. The most important point is that the moon's influence is subtle because a completely different night sky. Instead of the familiar moon, Earth could have a spectacular ring of lunar debris, reminding humanity how deeply connected our planet is to its celestial companion. Perhaps the most emotional consequence of the moon breaking apart would be the transformation of the night sky. For thousands of years, humans have looked upward and recognized the same familiar object shining above them. The moon has guided travelers, inspired stories, influenced calendars, and provided a natural light during the darkest nights. If it suddenly shattered, that familiar symbol would disappear forever. Instead of one bright disk moving across the heavens, Earth could eventually be surrounded by countless fragments of lunar material. Depending on how the debris spread, these pieces could form a broad ring or irregular bands around the planet. From the surface, the sky might look completely unfamiliar. Bright streams of reflected sunlight could create glowing arcs stretching across the darkness. The appearance would be spectacular, but it would also carry a sense of loss. The moon would no longer be a single world hanging peacefully above the horizon. It would become a collection of fragments, constantly moving through space. Some pieces might collide, while others could slowly change their orbits under the influence of Earth and the Sun. Over time, the debris could gradually spread, fall toward Earth, or settle into more stable paths. The brilliant ring might become thinner and less noticeable, meaning even this strange replacement for the moon would not necessarily last forever. For humanity, the psychological impact could be enormous. Imagine generations growing up without ever seeing a traditional full moon. Children would learn about it from historical images and scientific records, just as we learn about vanished civilizations today. The broken moon would become a permanent reminder that the universe is not static. Even the most familiar objects see